Hi, good morning. It's already 15 after 9. Okay, it's raining, so people are getting late. Um, okay, so today we are getting into Unit 7b. Okay, the reason that we have 7a, 7b is because that the course has two versions, right? The version 1 is Chinese, and the version 2 is English, right? So in order to keep the unit number, in order to unify the unit number, have to do some shuffling. Okay. So Unit 7b is for clustering and dimension reduction. Anyone have any idea about what clustering and dimension reduction is? Anyone? No, huh? Okay. Okay. This is this is two kind of data exploration technique. Okay, it's for explorative data analysis. But up to this point of time, when we explore the data, basically we just manipulate the data, right? Using the existing categorical variable to separate our customer, right? We separate our customer by their age, by their zip code, right? Okay, so in this way we actually can calculate the characteristic of each different age group, right? We can calculate that, we can compare the different behavior in different area, in different age group, right? That's a way to group our customer, right? The reason that we need to do grouping and then to group comparison is because that we want to do strategy, right? As I told you again and again, strategy is all about choice, isn't it, right? So you need to choose between the age group, you choose between the area that you want to focus on, right? Okay, and then you need to set the goal, right? Before you can set the goal for improvement, you need to know the current status of each individual group, isn't it, right? But up to this point of time, the grouping that we are using is based on the existing characteristic of the customer. For example, the age group, the zip code, they're already existing in the data, right? Right? The customer, for every customer, there is a column, right? In the column data frame, there is a column called age. There is another column called area, right? So this grouping are actually obvious, observable, existing, right? And sometimes we want to group our customer based on their similar behavior, based on their similar interest, their similar preference, right? If we group our customer by their age, now even they have some tendency, but the behavior, the interest or preference in the same area will be different, right? Right? Isn't it? Right? People live in the same place might have different interests. People in the same age might have different behavior, right? So for marketing purpose, or I should say in general, for managerial purpose, sometimes we want to group our subject with their behavior, right? Okay. Sometimes we want to group some object by some numerical variables. Okay. For example, I want to observe their amount of buying, average amount of buying, right? I want to group the buying frequency. I want to group people by their residency, right? This RFM type of variable. They are actually numeric variable, right? So if I can kind of group my customer based on their RFM, based on their behavior. It's easier for me to design some specific campaign, to design some managerial method that was specifically designed for this specific group of people, right? And it usually would be more effective, isn't it, right? That is the reason that we want to do clustering, okay, and dimension reduction, okay? I believe that the easiest way to explain clustering and dimension reduction is to use real example. So let's go into our notebook today, okay?
Sorry, your microphone is not working.
Microphone is not working? Oh, it's dead. That one need to use battery. Hello? Hello? Is it working now? It's not working. No, it's not working. Let me use this one. It's working now, right? Okay, so let's look at a real example, and it will give us better idea about what is clustering and what is dimension reduction. Okay. Now, today we will have. If you go to the folder, you'll see two files, right? And the first one is for is the PowerPoint, right? And the second one is the zip file. If you unzip the file, you will see there will be four notebooks today. I may only have time to go through 3 of them, but I believe that will be enough. Okay. Let's look at the 07A. As usual, we can open it in browser as well. Okay, let's take a look at the data. This data set is called wholesale data set. So this data set is from wholesale, and the wholesale, they are selling product to resellers, to retailers, okay? So this data have, let me read in the data so it's easier to see. This is to install, load the package that we want to use, and this is the data. As we can see, this is the wholesale data set, and I call it W, okay? So actually the data is quite simple. Now every row of this data frame is a retailer, because the wholesaler, they sell product to retailers, right? So each one of it is you can think it as a convenience store, right? And there are two different channels. Well, you can treat them as like 7-Eleven and the family. Okay? Okay, so they are two chains. And there are three regions. It's like the north, central, and the south. Okay? So every role is actually a retailer. And fresh, milk, grocery, frozen, detergent, and delicatessen, these are product category, right? And this is the amount that this retailer buy from the wholesaler. Okay? So this is actually the record of selling amount for 6 category of product. Is that clear? Okay? So this is the data, right? So if we apply clustering and dimension reduction at the end of the notebook, this is what we. Let's go to the result first. Okay. At the end of the analysis, each point represent a retailer. Okay. Each point is a retailer. Okay. And each color is a group. Okay. So we kind of separate the all of this 440 retailer based on the product they buy, right? We want to separate this 440 retailers into 5 groups, okay? Based on the product they buy, okay? So they are buying 6 categories of data of products, right? See, milk, grocery, and detergent, deli, fresh, and frozen, right? So we can see that this group, they buy, because as you can see that this is the dimension, right? So the group that in this dimension, they buy more milk, more grocery, and more detergent papers, right? And group that in this direction, in this dimension, they buy more frozen, fresh, and delicatessen. Okay? So after clustering and dimensioning, right, this 440 retailer can be divided into 5 groups, right? And in this group, they actually, what is the characteristic of this group? They buy this product very, the buying amount of milk, grocery, and detergent, they are very small, right? So they are in this, right? So they do not buy milk, grocery, and detergent. So they are in this group, right? And in this group, they actually buy for this 3 category of product, they buy a little bit more than this group, right? And these 3 groups, they are buying more milk, grocery, and detergent, okay? And within these 3 groups, they are also have difference in the amounts of these 3 category of product, right? So this group, they buy more of the 3 and more of this 3, okay? And this group, they buy more of this group, but less of this group, this category. You see that? Okay? So in this way, we actually have a very systematic and holistic idea, right? We separate the group based on their buying behavior, isn't it? Right? Now, the grouping information, this is the original data, right? But the grouping information is not here, right? They are divided into 5 groups, but the grouping information is not here. We need to use some algorithm, right? With this raw data, we need to use some algorithm to do clustering and to do dimension reduction. Okay? And after we apply this algorithm to this data, we can have a better idea about the the buying behavior of our customers. Get the point? Okay, this is the purpose, right, of clustering and dimension reduction. Okay. Any question? Now, without doing clustering, we can already map the data into the space, right? So even without doing this, if we have this data, we can actually do some mapping, right? For example, if I want to if I use ggplot, and if I do it this way, okay? If I do it this way, I'm actually using this I'm actually using this region as the grouping variable, right? And the region is actually a categorical variable, right? See? And let's see what will happen. See? Okay? You cannot see the similar behavior in the same group, right? You see that, right? But after the clustering, because this grouping are actually based on their profile, right? Okay. But if I'm doing clustering, I actually can, right? And I actually can separate them with their similar behavior, right? So that is the benefit of clustering. When you do clustering, you will have the similar, you have the group of similar interest, similar behavior, similar preference, so that you can design a specific campaign, design a specific managerial method, and usually it will be more effective within the group, right? Okay. Okay, let's keep looking into the data. Now, this is the way to do, the one way to do clustering in R. Okay, in this course we do not have the enough of time to kind of do the mathematics explanation. Okay, so I simply try to cover the idea of clustering with a few slides. Okay, you really don't need to learn the mathematical things. You really don't need to write program, because in R there are existing tools to help you to do this clustering, right? So you fit in the data, and as long as you know how to interpret the outcome, then the clustering can be kind of like automatically by this tool. Okay, but still we need to have some basic understanding about what is clustering, right? Okay. Actually, before doing clustering, basically we need to map all of the element, all of the subject into a space. Okay. For example, if I want to clustering the point x1 with x1 and x2, okay. For doing traditional clustering, the variable has to be numeric variable. So because they are numeric variable, so we can use this numeric variable as a dimension in the space, right? So if we are only interested in 2 dimension, it's easy, right? We just use the clustering variable as the dimension, as the coordinate, right, of every retailer, right? In this way, we can kind of like map every retailer into the space, right? So and the principle of clustering is actually to reduce the distance within group, okay, and increase the distance between groups, right? Because we mapped all of this retailer into a space, right? So the retailers that has similar behavior would close to each other, right? So in this space, the variable mapped to the dimension, and the distance actually mapped to the difference, isn't it? The distance between the points can represent their difference in buying behavior, isn't it, in this space, okay? So we have an algorithm, an already existing algorithm, you call a function, okay? And the function would kind of like this clustering algorithm will try to reduce the distance within group, right? And increase the distance between groups. Okay. Actually, this algorithm it cannot move the point, right? The point is fixed in the space because they are the value of these 2 variables are used for their coordinates, right? So the coordinates do not move. What the algorithm do is actually they determine which point belongs to which group, isn't it? Right? It actually just draw the boundary of group in the space, okay? It did not move the point, okay? And when they draw the boundary of the group, they try to follow this principle, okay? And there are a lot of different algorithms to do clustering, okay? So in this class, I will teach you like 2 of them, okay? And the way to use this algorithm is quite easy in R, okay? I'll explain them later, okay? Okay, so maybe we have a basic, have some more detail about the algorithm, right? Okay, so as you can see that they are, in the beginning they are separate points, right? Okay, so one way of doing clustering is called hierarchical clustering analysis, okay? So this algorithm, it basically works this way, right? In the beginning, all of the subjects are within the same group, right? Okay, and then in this group, it divides into 2 groups, okay? If I divide into 2 groups, this is the first and this is the second, okay? And for each group, I keep repeat this process, okay? First of all, I divide the whole data set into 2 groups, okay? And then I try to divide each group with 2, okay? As you can see that I divide this group in this one and this one, okay? And for this one, I further divide it into this one and this one. And I do it again, again, and again, right? So it kind of like, it look into the data point, right? In the beginning, all of the data points are in the same group, okay? And first of all, I try to cut them into two groups, following this this principle, okay? I divide them into two groups. So as you can see that after the division, the height of this horizontal line actually represent the height of the horizontal line. It represents the average distance to the group center. Okay, so if I'm in this situation, all of the points are treated as a same group, right? If they are treated as the same group, actually the center will be somewhere here, right? And because they are treated as the same group, so the distance, the average distance to the group center are longer, isn't it, right? So if I only if I treat all of the data point as in the same group, then the average distance, right, to the group center is actually longer, right? So if I divide them into two groups, right, as you can see that the distance to the center is like reduced very significantly, right? Okay? You see that, right? This is the, I do not divide. If I divide it into two groups, then the average distance to the center of this group reduced from this height to this height, okay? And the average distance of this group actually reduced from this height to this height, right? And that is the algorithm do for you, do for us, okay? We just give it the data, and then the algorithm will keep doing this for us, okay? It would like hierarchically divide the entire group into two and repeat this process again and again, okay? So after the result of hierarchical clustering analysis is kind of like a tree, okay? It's like a tree. So then you can determine how many groups you want to keep, right? If I cut here, I will have two groups, right? If I cut at this point, I will have three, right? If I cut at this point, I will have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I have 5 groups, right? If you cut it higher, you will have less group. If you cut it lower, you have more group, okay? So after the clustering, you can determine how many groups you want to keep, right? Okay, so there's a question. How can I determine the number of groups, okay? That is actually do not have a fixed answer, right? It depends. It depends on your business purpose, okay? Actually, in the context of business and analytics, the number of groups are usually you just try and error, right? You try to divide it in two groups, divide it in 3, in 4, in 5, in 6 groups, and you see the result of the and you observe the result of the grouping, right? Okay, and choose the one that fit your purpose the best. Okay. Let me say it again. If you are using this hierarchical clustering analysis, the result is a tree. Okay, it's a tree of hierarchical clustering. Okay, you can cut them into 2 groups, 3 groups, 4 groups, right? As you wish. Okay, and after cutting the group, you can observe the result. Okay, and if the result fit your purpose, then it's a good clustering already. Okay, and sometimes you can you can apply this to the real data. it's there are some criteria that that to determine whether the number of grouping is good or not, right? If after the grouping, each of the individual group is observable, is easier to observe, right? It's easier to manipulate. It's easier to communicate, right? If after I divide the group, it's easier to observe, right? They do not to have too much overlay between each other, right? It's easier to observe. It's easier to distinguish, right? Easier to communicate, right? Easier to manipulate. Easier for you to do your operation, right? Then the number of group is good. Okay, if not, you just try and error and try more group or try less group. Okay. See, actually, if you divide them into too many groups, sometimes it's very difficult to operate, right? But if you divide them into too few, then some group might be too blurred, right? It do not have a very specific characteristic. So there are a trade-off, and there is no fixed answer. You need to do some try and error to determine the number of groups you want to do. Okay. So we know the ideas of clustering already, right? And how about dimension reduction? Okay. So for the purpose of easier illustration, I start with 2 dimensions, right? You have two variables, but actually in this case, we actually have 1, 2, 3, 4, 5, 6. We have 6 numerical variables instead of 2, right? So when you want to map each variable into a dimension, this 6 variable will become a 6-dimensional space, right? And it's very difficult to imagine a 6-dimensional space, isn't it? Right? Okay. So what we mean by dimension reduction is we try to compress the 6 dimension into a 2-dimensional space. So originally they are 6 dimensions, right? Every variable is a dimension, right? But for visualization purpose, right? For easier to understand purpose, we actually can kind of like compress the dimension and press them into a 2-dimensional space. Okay. So every original dimension will be a direction in this 2-dimensional space. Okay. So it's easier for us to see the result, right? If we do not use dimension reduction, we can only observe 2 dimensions, right? But it is desirable, right? It's for business purpose, it is desirable to see the holistic situation, right? So if you want to do a strategy, you want to use the variables that are relevant to that strategy, right? And if there are a lot of different variables, you want to compress it into 2 dimensions so that you can do the observation and do your planning a lot easier, isn't it? Right? And this technique is called dimension reduction. Okay? It uses this it starts with the 6-dimensional data, this 6 numeric variable, and compress it into a lower dimension. Okay? And that is what we mean by dimension reduction. Okay? So after the dimension reduction and clustering, we'll see the results like this. right? Okay, you have a very good idea about the different buying behavior with all of this. You divide the 440 retailer into 5 groups, and each group have a unique, right? Have a unique buying behavior, right? They have a different buying amount in these 6 categories of products, right? That is clustering and dimension reduction, okay? Different from what we already have learned. What we already have learned is actually just some simple statistic and visualization, right? But in order to do this, you need to do some multi-variable algorithm, okay? We do not have time to go into the algorithm in detail, but I will tell you how to do this in R, right? In R, all of this algorithm already been encapsulated in some package. So as long as you can do, as long as you know how to call the function, then you can do it very easily, okay? Now let's take a look at this. Let's take a look at how we are going to do hierarchical clustering. As I told you, we have a lot of different clustering algorithms. Hierarchical clustering is just one of them. It's an easier one, I should say so. Okay. Now, actually, to do hierarchical clustering, you need to write a line like this. First of all, let's start with the 2 variable. Okay. For better understanding, right? We have 6 variable, but let's start with 2 clustering variable. The 3rd and the 4th column. Okay. So this is the data, right? So in order to do hierarchical clustering, you actually use a pipe. Okay. First of all, you do a scaling, and then you do a distance, and then you do a hierarchical clustering algorithm, right? Okay? Now, there are a few steps. In order to do hierarchical clustering, there are a few steps. The first of all is to do the, of course, the first of all is the data, right? You fit the data and you scale the data. What we mean by scaling is kind of like standardize the variable. Okay? Sometimes the variable, they are in different scale. See, let's go back to this chart. It's easier to explain. Right? Sometimes x1, the scale of x1 is from 0 to like 1 million, right? So the scale is very big, and the scale of x2 is like is between 1 and 0. Okay, so if you put these 2 dimensions without scaling them, now the distance in x2 is like will be like ignored, right? Because if they are in different scale, right? If these 2 dimensions are in very different scale, then the smaller scale do not have the same weight as in the large scale, right? So when you are doing clustering, usually you want to have the same weight, right? The same weighting of all of these clustering variable, right? So if the variable, the original variable are in very different scale, you use this scale function, right? Try to standardize the variable. It means that when you do the standardization, the column is subtract by their average and divided by their standard deviation. After this scaling effect, every column would have a average of 0 and standard deviation of 1. Okay. which means that we want to, no matter what the original scale is, before we do the clustering or dimension reduction, usually we need to like standardize the scale of this dimension. Okay? Standardize the scale of all of the dimension, so that when we do the clustering and when we do the dimension reduction, all of these variables are of the same weight. You got it? Okay. So, but in R, you don't really need to do the math. You simply like fit the data into scale, and then you do distance. Okay. Because we want to, as I say, that this clustering algorithm is based on this principle, right? So in order to apply this principle, you need to calculate the distance between every point. Okay, you need to calculate distance between every point, and so in this case, because they are 440 data point, right? So it kind of like calculates distance between each of the 2 points, between each pair of points. There's a distance. So up to this point, there will be a distance matrix, okay? And then you use the hierarchical clustering function. You use this function to, it died again, right? No, it maybe you want to go to Guandian and have some more battery. Okay. Okay, let me kind of speak louder. Okay. So the last thing is like after you have this distance metric, you actually pipe it into the hierarchical clustering algorithm, and the result will be an object called hierarchical clustering. Okay, the outcome of this line of code is actually a data object. Okay, and you plot the object, you will see a dendrogram like this. This kind of graph is called dendrogram, and because we have 440 data point, right? So it's kind of like very crowded in the lower part, right? So usually you don't really need to plot this dendrogram. This is just for like for explanation, right? So in practice, you don't really need to like plot the HC, plot the tree. Okay, so after you plot the tree, you can cut the tree into as I say, that you can determine how many group you want, right? If you want to cut it in 6, then you do a command like this. Okay, you would divide the entire thing into 6 groups. If you want to use 5 group, then you use 5, right? Okay, let's do some practice. As we can see here, I use this line of code to do the clustering, right? So it's easy, right? This is data, and after this pipe, it will generate it will generate the object called HC, right? And if I plot this object and then cut it into 6 groups, this is the result, okay? If for some reason I only want 4 groups, I can do it like 4, right? Then we have 1, 2, 3, 4. We have 4 groups, right? If I want to do 3 groups, I do 3. And see, now you have 1, 2, 3. You have 3 groups. You see that? Okay. And usually we will do it like this, right? Okay. So here is the W is our original data frame, right? So if I want to divide it into a group, usually I would do this. I would use this object, and I call cut tree, okay? And the K is the number of groups that I want, okay? If I want to cut them into a group, usually I will put the result. I will change the result as a factor, and then put it in the same data frame, right? As group. As you can see that here we do not have group, right? Okay, but now I use this cut tree to generate a clustering vector, right? And I put this cluster vector as a column in the data frame, so it's easier for me, right? After I run this, I will see a group column within the W data frame. See that? Okay. So and then I can like usually I can do a table, right? So I'll see that the first group has so many retailers, right? And as you can see that some group has very few numbers of retailers, isn't it? Right? And some group have more members in there. Okay? So this is a way to do hierarchical clustering in R. Let's take a break, right? And then we'll be back in 10 after 10. Okay?